Okay, so year 12, what we're going to do here is have a look at multiplying and dividing algebraic fractions. We'll also cover kind of adding and We'll also cover adding and subtracting algebraic fractions in the same lesson, because this is kind of more of a recap of some GCSE work than anything else. I know you'll all be absolutely fine with it. So to start with, if you've got a over b times c over a, when you're multiplying fractions, you multiply your numerators, you multiply your denominators. It makes sense though to cancel any common factors before you start. So here, because this has got an a and this has got an a, they cancel out. And we are just left with c over b. With this one here, it's similar, but we're going to look and see if we can factorise anything to cancel common factors before we start. So what I know is that x squared minus 1 can be factorised in the form x plus 1, x minus 1, because it's the difference of two squares. So when I factorise, I get this, 2 times by 3, x plus 1, like that. And so now, this x plus 1 and this x plus 1 cancel out, and so we are left with 3 over 2 brackets x minus 1. The question here didn't ask for it in a particular form, but you might also want to write that as 3 over 2x minus 2, and that would be okay. Just here then, in terms of division of fractions, we know that when we are dividing, we know that when we are dividing fractions, we are multiplying by the reciprocal. So here, we've got p over q divided by r over q. That is the same as p over q multiplied by the reciprocal, which is q over r, like that. Then we just cancel out any common factors, and so we are left with p over r. And then a final one, so same thing, we are multiplying by the reciprocal. So first of all, I would rewrite this and then we're going to look and see if we can factorise anything and therefore cancel. So here we can 100% do that, because the left hand side can still just be written as x plus 2 over x plus 4, but the right hand side can be written x squared minus 16 factorises as x minus 4, x plus 4, and then my denominator, this 3x plus 6, factorises as 3 brackets x plus 2. And so now it looks like that we can do some cancelling. So this x plus 2 and this x plus 2 cancel. This x plus 4 and this x plus 4 cancel. And so then all we are left with is x minus 4 over 3. And that's it. So exercise, this is kind of exercise 1b. I would imagine you will all be absolutely fine with this. The main thing is just, if you're not quite as quick at factorising, it will take you a little bit longer. So that's like the only really difficult bit here. But you'll all be absolutely fine with it. Good luck. Okay, so the second part, year 12, adding and subtracting algebraic fractions. As you already know, when you're adding or subtracting fractions, they need to have the same denominator. So that's what we need to do here. What you should always look for though, is if anything can be factorised. And the reason we're going to do that is to make them have the same denominator. I could just multiply these two terms, but that's going to be more complicated than necessary. So first of all, if we rewrite this as 3 over x plus 1 minus 4 over, and this factorises as x minus 1, x plus 1. And so what that means is my common denominator is going to be x plus 1 and x minus 1. That will be my common denominator. X plus 1, x minus 1. So then all we need to do is use our idea of equivalent fractions to help us get there. So this first fraction, I've changed its denominator from being x plus 1 to being x plus 1, x minus 1, and therefore I need to times my numerator by x minus 1. You can just do this all in one step, but I'm going to write it as 3 brackets x minus 1. And then this here is 4 over x minus 1, x plus 1. The denominator is still x plus 1, x minus 1, so I don't need to do anything to the numerator here, so it's just minus 4. And after that, I would leave my denominator as it is, but I would simplify the numerator here. So leaving the denominator, and in terms of my numerator, I get 3x minus 3, because 3 times minus 1 is minus 3, minus 4 is minus 7. And that's how I would leave my answer there. So a second example of that type, just to kind of help. So here we've got 10x plus 4 over 3x squared plus 4x plus 1 minus 3 over x plus 1. So first of all, we're going to want to factorise this left-hand side denominator. Now, as a clue, because this is an x plus 1, you're almost certainly going to get an x plus 1 here. Okay? And that actually works, because 3x squared plus 4x plus 1 factorises like this. 3x plus 1, x plus 1. So then, after that, we need to make them have the same denominator. Our denominator here is going to be 3x plus 1, x plus 1. My first fraction, the numerator, stays the same. So the first fraction still has got a numerator of 10x plus 4. Then this second fraction, to get from x plus 1 to 3x plus 1x plus 1, I've times by 3x plus 1. And so doing that, so minus 3x plus 1. I would really recommend, particularly when you are doing it with subtracting fractions, that you do it in these two steps, because otherwise people make mistakes with their negative signs to around about here. So now just expanding out the numerator. So expanding out the numerator, I am going to get 10x plus 4. Then it will be minus 9x minus 3, because minus 3 times 1 is minus 3. Then simplifying this down, 10x minus 9x is x. 4 minus 3 is 1. So we've got x plus 1. So now our numerator has simplified down to x plus 1. My denominator is 3x plus 1, x plus 1. And so what happens is this x plus 1 and this x plus 1 cancel out, and therefore we are left with 1 over 3x plus 1. That's our final answer in its simplest form. Okay, let me just move this, you can see. So that's our final answer in its simplest form. I hope that's been helpful. You're going to have a go now at exercise 1C, I think it is. This should be quite straightforward, but it is really important that you're completely fluent, because that will make the work we're doing next on partial fractions, which is exciting, really easy. So good luck with that, and let me know if you've got any more questions.